What if you could plug your phone directly into a river? It sounds like science fiction, but the core idea is closer to reality than you might think. Imagine a power source that never sleeps, a silent, tireless engine of nature. It flows day and night, rain or shine. Unlike solar panels that depend on the sun or wind turbines that need a breeze, this energy is always there, a constant pulse of power. This power source is not a giant dam. It does not require flooding vast areas of land or altering entire ecosystems. It is the simple, steady movement of river water, a force hidden in plain sight. This is the promise of river kinetic energy. It is a technology that taps into the natural flow of our waterways with minimal disruption. We can use this constant motion to generate electricity, creating a predictable and stable supply of clean energy. This method offers a reliable way to power our homes and communities without the large environmental footprint of traditional hydropower. In this essay, we will demystify this process and explain how we can turn a river's gentle flow into usable electricity. We will explore a technology called river kinetic turbines. These devices work much like underwater windmills, but with a key difference. They capture the energy of moving water instead of moving air. And since water is nearly 800 times denser than air, even a slow-moving current packs a significant energetic punch. The process is straightforward and elegant in its simplicity. First, a turbine's blades are placed in the river and begin to spin in the current. This spinning motion drives a generator, converting kinetic energy into mechanical energy. Finally, the generator then produces electricity, ready to be sent to the grid. We will walk through each step of this process in detail. You will see how a simple current becomes the power that lights up our upper room. We promise a clear and simple explanation, breaking down the science into easy-to-understand concepts. We will look at how this technology works from start to finish. We begin with the basic energy present in any flowing river. Then we will see the different types of turbines designed to capture it, from horizontal axis models to more unique vertical designs. You will learn how engineers decide where to place these machines for maximum efficiency and minimal impact. They must consider the river's speed, its depth, and its existing uses, ensuring that navigation and recreation can continue undisturbed. We will cover the journey of the power from the riverbed to the electrical grid. This includes the specialized underwater cables, the converters that prepare the electricity for the grid, and the final connection to your home. It's a fascinating system that provides clean, predictable power with a gentle touch. This guide is for anyone curious about sustainable energy solutions for our future. You do not need a background in engineering to follow along. We will use simple language and relatable examples. We will avoid complex jargon, and when a technical term is necessary, we'll explain it clearly. Our goal is to show that understanding this technology is accessible to everyone. By the end, you will understand not just how river turbines work, but why they matter. You will also know their distinct advantages, like their predictability and small footprint, and their limitations, such as site-specific requirements and maintenance challenges, when compared to other renewable energy sources. Let's begin our journey into the quiet, consistent power that flows unseen in our rivers. This is a story about turning motion into light and harnessing nature's rhythm for a brighter, cleaner world. All moving things carry energy. It's a fundamental principle of physics, a force present in every object that travels from one point to another, whether it's a planet orbiting a star or a single raindrop falling to the earth. A car driving down the road has energy, a product of its mass and velocity. A ball thrown through the air has energy, propelled by the force of the throw. This energy is called kinetic energy. It is the energy of motion, and it is all around us in countless forms. Rivers are no different. In fact, they are one of nature's most powerful and consistent expressions of this principle. A flowing river is simply a massive amount of water in motion, pulled relentlessly by gravity toward the sea. Each drop of water contributes to a powerful collective flow, a liquid engine that never stops. This moving water carries a tremendous amount of kinetic energy. It is this invisible force that we can capture and convert into a usable form of power. Imagine the relentless push you feel when wading into a strong current. That push is the river's kinetic energy at work, a constant pressure waiting to be harnessed. The idea is to tap into this natural movement, to work in harmony with the river's existing path. We are not stopping the river or holding it back with large dams. Instead, we are borrowing a small fraction of its energy as it passes by, leaving the river to continue its journey. Think of it like a pinwheel in the wind. It's a simple, elegant analogy for a powerful concept. The pinwheel spins because the moving air, which has its own kinetic energy, pushes against its blades. It does not stop the wind, it just uses its motion to create a delightful spin. A river turbine works in the same way, but underwater, where the flow is more predictable and concentrated. The flowing water pushes against the turbine's blades, causing them to spin. This simple, continuous motion is the first step in generating electricity from a river's natural flow. It is a gentle way to work with nature, but the power it can unlock is far from gentle. This energy source is incredibly dense. Water is much heavier than air. This is a fact we experience every day, but its implications for energy are profound. To be exact, water is about 800 times denser than air. This means that for the same speed, moving water packs a much bigger punch than moving air. A slow-moving river current can contain more energy than a very strong wind. This density is a key advantage for river power. It's the secret ingredient that makes this technology so promising. It allows turbines to be smaller and more compact than wind turbines, while still generating a significant amount of power. The sheer weight and force of the water make it a potent source of kinetic energy, even in currents that seem gentle on the surface. So the fundamental principle is simple. We place a device in the path of moving water. The water's kinetic energy forces the device to move. In this case, it forces a turbine's blades to rotate, much like the current of a river turns a fallen branch. This rotation is a form of mechanical energy captured directly from the water. It is a clean and direct transfer of energy from the flowing river to our machine with minimal loss and maximum efficiency. We are not burning any fuel. There is no combustion, no smoke, no finite resource being consumed. We are not creating any emissions. The process is as clean as the river itself. We are just converting one form of movement into another, from the linear flow of water to the rotational motion of a turbine. This is the clean, simple heart of river kinetic power. It is an elegant way to draw power from the world around us, transforming the constant, quiet strength of our rivers into the energy that lights up our lives. To truly understand a river's immense power, we can't just admire its beauty. We have to quantify it, to translate the raw, untamed force of nature into numbers and data. To do that, we must measure its flow. And when it comes to generating energy, one factor stands above all others. The most important factor is the speed of the water. This is often called the flow rate, or more technically, its velocity. It is measured in meters per second or miles per hour. A faster river carries much more energy than a slower one. The relationship isn't linear, it's exponential. This means even a small increase in speed can lead to a very large increase in available power. Doubling the speed, for instance, increases the power potential by a factor of 8. This is why engineers look for rivers or specific sections of rivers where the water moves consistently and quickly. They use special instruments called current meters to measure this speed at different depths and across various locations. This detailed mapping helps them find the sweet spot for placing a turbine. But speed is only part of the story. Another crucial measurement is the cross-sectional area of the flow. This is essentially the width of the river multiplied by its average depth. So width times depth gives the cross-sectional area. Think of it as the size of the window through which the water is flowing. A wide, deep river has a large cross-sectional area. It means a greater volume of water is passing a single point at any given moment. More water in motion means more mass and therefore more total kinetic energy available to be captured. When we combine these factors, we get the fundamental equation for available power. It looks like this. Power equals 1/2 times the density of water times the area of the turbine times the water speed cubed. Now, you do not need to memorize this. The key takeaway is that speed or velocity is by far the most powerful ingredient in this recipe because it's cubed. The other parts are also important. The density of water, represented by the Greek letter rho, is fairly constant. It's incredibly dense, about 800 times denser than air, which is why even slow-moving water has so much force. The area of the turbine is something engineers can choose. A larger turbine can capture more water, increasing the A in our equation, but it is also more expensive, more complex, and harder to install and maintain. So engineers must balance the turbine size with the river's conditions and project economics. This equation helps us estimate how much power we can theoretically get from a specific spot in a river. It sets the upper limit, the total energy present in the moving water. In reality, no turbine is 100% efficient, so we can never capture all of the available power. There is a physical limit known as the Betz limit for turbines, which states that no turbine can capture more than about 59% of the kinetic energy. Real-world river turbines are typically less efficient than that, maybe capturing 30 to 40% of the energy in the flow due to mechanical and hydraulic losses. But because water is so dense and the power scales with the cube of velocity, this is still enough to generate substantial useful electricity from a steady current. The physics provides a clear roadmap guiding engineers from the riverbank to the power grid by harnessing this incredible renewable force. Installing a river turbine is a major marine operation. It requires careful planning and specialized equipment. For a bed-mounted turbine, this may involve drilling into the riverbed to secure a steel monopole. Once the foundation is secure, the turbine itself is brought to the site on a barge equipped with a crane. Divers often assist in this process, ensuring everything is aligned and securely bolted together. Once installed, the system needs regular maintenance to ensure it runs smoothly for its entire life. Most maintenance involves remote monitoring. Remotely operated vehicles, or ROVs, may be used. The expected lifespan of a river kinetic turbine system is typically around 20 to 25 years. This is comparable to the lifespan of wind turbines and solar panels. However, some parts may need replacement during this time. At the end of its operational life, the turbine must be removed from the river. The materials from the turbine, mostly metals like steel and aluminum, can be recycled. This commitment to removing the equipment and restoring the site is a key part of the technology's promise of low environmental impact. We have followed the journey of energy from a simple river current to the electricity that powers our lives. Section 2. The future flow of river power. Turbines are becoming more efficient and less expensive. We are also seeing advancements in designs that are even safer for aquatic life. River turbines are perfectly suited for powering remote communities that are not connected to a large electrical grid. It can bring light to schools, power to health clinics, and new economic opportunities. Looking ahead, river turbines will likely find their place as part of a diverse energy portfolio. It can provide the firm baseload power that is needed to balance the intermittent nature of wind and solar. This synergy makes the entire renewable energy system more robust and reliable. If you live near a suitable river, consider its potential as a source of clean local power. River kinetic turbines offer a way to tap into the planet's natural rhythms, turning the constant motion of water into a brighter, more sustainable future for all. The power is already there, flowing steadily day and night. We just need the vision, the technology, and the will to harness it.